Okay, so we're going to start with some basic concepts, and that is we're going to talk first about something called the perpendicular bisector. And then we're going to look at perpendicular bisectors of a triangle and see what happens. Okay, so here I have a segment called AB, perpendicular bisector. So I'm going to ask you, Jessa, what is a perpendicular bisector?
A line that like is interfered with something or another line, maybe.
Keep going. Look at the name. A perpendicular bisector.
So then it's a line that's maybe interfered with two lines?
No. Via, your turn. What's a perpendicular bisector?
A line with 2 points, like specific points on it?
Keep going. All lines have 2 points on it, so what? Now, hold on, let me clarify. This picture I have drawn is not a perpendicular bisector. This is just a segment. What I want to know is, what does a perpendicular bisector of this segment look like? And once we get a definition, I will draw it in for you. But if I draw it in, it'll be too easy. Via, you want to try again?
Do lines go through the 2 points that are in a line segment that are already there?
Nope. Okay, again, look at the name, perpendicular bisector. Ella, what's a perpendicular bisector?
Not sure.
Aiden?
It's a line that goes through the line you have, and it's a right angle.
Good. That takes care of the perpendicular part of the name. So when you said it goes through the segment, where does it go through the segment?
Couldn't it be anywhere?
If it was anywhere, okay, so hold on. Yes and no. Let me draw the picture here. So I could do this. Okay, and that would be perpendicular. That would take care of the first part of the name of the figure, but we're talking about a perpendicular bisector. So what do I have to do to this puppy in order to make it a perpendicular bisector? Over here it's perpendicular, over here it's perpendicular, over here it's perpendicular, but we still haven't taken into account that part of the term. Aiden, you want to try again?
Put it in the middle.
Good. If that is in the, you use the term in the middle, what's special about that point? Aiden.
That's like the halfway point, like the midpoint.
There we go. That's the word I was looking for. That's the midpoint. Okay? So let me clean this up a little bit. Good. Thank you, Aiden. Okay, and as he said, it's perpendicular. Could we find the equation of that pink line? Colin?
Yeah.
Okay, so let's start with some points. Colin, where would you like the point A to be? Just give me some coordinates. It doesn't matter.
0, 1.
Okay, way to get crazy there. And how about B?
5, 6.
Ooh. Okay. So if we know the endpoints of that segment, you're telling me that we can find the equation of the pink line, yes?
Same.
Okay, good. So, Ethan, what are the two things we need for the equation of a line?
At least one of the angles. I mean, at least one of the points.
Good. We need a point and
Like the degree of it,
also known as
the angle.
also known as anybody?
Slope.
It's a slope, correct. So we need a point and we need a slope. And that's true for any line, any equation of a line. Okay, well, if we look at the picture that Aiden helped us with earlier, we have a point, M. I don't know where it is yet, but I can get there. How do I find the slope of the pink line? Lily?
I'm not sure.
Can you find the slope of the white line, or the white segment, I should say?
Yes.
Okay, tell me how. So we'll do this down here. Slope of AB.
Y2 minus Y1
Love it.
over X2 minus X1.
Beautiful. So it appears that we just, it appears that Colin gave me coordinates that give us a perfect slope of 1. Isn't that adorable? That won't happen very often. Okay. So if we have the slope of the white line, how do we find the slope of the pink line? Anybody? What's the relationship here?
The lines are perpendicular, so isn't the slope the opposite?
Beautiful. Well done. Okay, so the slope of the perpendicular. Good. Okay, and some of you are going to be completely confused. But this is stuff that we've done ad nauseum. That's Latin for until you puke. Finding midpoint should be second nature. Finding slope should be second nature. Taking a flopposite is second nature. So then we can put that together to get the equation of this line, which is, hold on a second, let me clean this up a little bit. I'm going to shrink this down. Maybe not. I'm going to shrink this down. And move that up there. Okay. And then the slope, or the equation of this line would be y minus, oh, wait a second. We didn't find m yet. How do we find the location of m? Nico, ideas? How do I find out where m is?
I'm not sure.
Rachel?
I'm also not sure.
Leah, go.
N is the midpoint of both lines, so we just have to find the midpoint.
Okay. And how do we do that? Refresh my memory. Ooh, I gotcha. Anybody else? How do you find the midpoint?
Using the midpoint formula?
Good. 0 plus 5 divided by 2, comma, 1 plus 6 divided by 2 puts m at 5 halves, comma, 7 halves. Good. Okay, so y minus 7 halves is equal to -1 times the quantity, x minus 5 halves. We're going to put a rectangle around that because that is important. how to find the equation of the perpendicular bisector by finding the midpoint and the perpendicular slope. Questions so far? Now, I know you have some questions because you don't remember how to find the midpoint. You don't remember how to find the slope, but that's on you. That's something you should know by now. So before we go any further, let's take a look at something else that happens. And so I'm gonna expand this problem and start with a triangle. So I've got this triangle labeled A, B, and C. And I'm using a program that's doing a lot of stuff for me. So it's going to be a lot easier here than it'll be for you because you're going to have to do a bunch of calculations. But we did the perpendicular bisector of a segment AB. Found the equation of the line, good to go. Now, what if we do that for all three sides of a triangle? Okay, well, first things first, you'd have to find the midpoints. Now, you would have to calculate those midpoints, but with the magic of this program, I just click a button and they appear. The same is true with the perpendiculars. Now, all of a sudden, I create the perpendiculars, and something bizarre happens. All of a sudden, I realize that all three of those lines, which are the three perpendiculars of a triangle, intersect at the same point. Okay, that point is called the circumcenter. All right, so let's go back here. We're going to move this up a little bit. So a circumcenter is defined as a point of intersection, which we commonly call a POI, of the perpendicular bisectors of a triangle. You take any triangle, you find the perpendicular bisectors, and for some bizarre reason, they will always meet at the same point. And the reason I wanted to show you this program, even though it cheats, is because if I grab one of these points and drag it, try that again, there we go, I can change the shape of the triangle, but notice the three lines always intersect. Doesn't matter what shape the triangle is. Now, you'll also notice some bizarre things happen. Like, for instance, sometimes the circumcenter is in the center of the circle, sometimes it's outside the circle, and sometimes it's even on the circle. And in the future, we're going to talk about what kind of triangle it has to be. Like, for instance, if I stop there, the circumcenter is on the triangle. What kind of triangle does that appear to be?
Right triangle?
Right triangle, right. So if I turn it into, let's say, an acute triangle, the circumcenter is inside, but if I bring this way over here and make it into an obtuse triangle, all of a sudden the circumcenter flies off the picture. There are 4 of these centers. This is the first, the circumcenter. Okay? And they will always intersect there. So what we're going to do is we're going to work our way through all 4 centers, and then we're going to start talking about some of the other properties associated with these centers. Okay? So for instance, if I do this, you'll see that a circle magically appears. The center of that circle is the circumcenter point. And if I drag this, you'll see that the circle passes through all 3 points of the triangle, all 3 vertices of the triangle, and will always pass through the 3 vertices of the triangle. But again, that's for later. We don't care about that right now because we haven't really talked about circles. Okay? So, when in your notes where you have the definition of the circumcenter written down, we're going to list some properties here. I know this is repetition, but bear with me. Center of the circumscribed circle. Circumscribed, drawn around. Circum, around, scribed, drawn. So drawn around. We'll have more properties, but we'll get to those later. So just leave yourself a little bit of space after this for when we come back to it. Okay, questions so far? We're good? All right. So I'm going to create another slide. And I'm going to put a
Wait, can you go back?
Sure. Let me know when you're good. All right, here we go. So now we're going to start with a triangle. Let's see. We'll do a triangle. This will work. Okay. A, B, C. We're going to do the work now that I just did using that other program, and it's going to be a little bit more complicated than just clicking buttons. We're going to have to actually do some work. So A is at -3, -4. B is at 1, 7. And C is at 8, -9. I have no idea if that's what the triangle would look like, nor do I care. I just know that when I do the 3 perpendicular bisectors, they're going to meet at the same point. And because I've done this before and I'm a little bit more intelligent than you think I am, you'll notice if I take one of these perpendicular bisectors and I hide it, I can still find the circumcenter. So I'm going to save myself a lot of hassle. Why go and find all 3 when I can just find 2 of them? So let's start with the perpendicular bisector of AC. So I'm going to need this midpoint. In fact, I'm going to label all 3 midpoints. And I'm going to label them, let's see, midpoint of AB is R. The midpoint of AC is T. And label this S. I'm going to find the perpendicular bisector of AC. And then I'm going to cut you loose to find the other perpendicular bisector. And then we'll talk about how to find the circumcenter. Oop, I'm off a little bit there. Okay, there we go. All right, so I'm finding the equation of that blue line. Because I'm assuming that most of you are taking notes on your iPad, make sure to make your life a lot easier. 2 things to consider. Number 1, make sure everything is labeled correctly. And number 2, make full use of the colors that you have available. If you're taking notes on paper and pencil, then get some colored pens or something. It'll be a lot easier to keep track of this stuff as we go. Okay, so I'm going to start by finding the point T. The point T would be at -3 plus 8 divided by 2, comma, -4 plus -9 divided by 2, which puts T at 5/2, comma, -13/2. And also, if I lose anybody along the way, just holler and I'll back up and explain things. Okay, now I need the slope of AC. -9. Whoops, -9 minus -4. So that'd be +4 over 8 minus -3, which is -5 over 11. Ooh, that's ugly. But again, I don't care because I know how to take a flopposite. The slope of the perpendicular would be 11/5. Flip it over, change the sign. Now I put all that together. I have the equation of that blue line is then y plus 13/2 equals 11/5 times x minus 5/2. Okay, now some of you might not like it in that form, in point-slope form. You might like that in y-intercept form. I can easily convert that to y-intercept form by doing 11 divided by 5 times negative 5/2 and subtracting 13 divided by 2. Which gives me, this turns out to be something pretty like y equals x minus 12. This I'm going to need later, so I'm putting a rectangle around it so I can find it easily. Either form of those lines you can use. You don't necessarily need that last step I used if you just want to leave it in point slope form. Questions so far? Okay, that's just a repeat of what we did. So now I'm going to change colors and draw in the other perpendicular bisectors. Whoops. Wrong tool. Hold on. Let's try that again. Do this one. And what other color can I use here? Let's use gray. Nope. Come on, Reedy. Great. There we go. Okay, so I drew in the perpendicular bisector of AB in red, and I drew the perpendicular bisector of BC in gray. And my ultimate goal here is to find the location of that point, which we'll call Q. And that point is the circumcenter. Now, how do we find that? Okay, so what you're going to do with your group then is you're going to find the equation of either the red or the gray. I don't care which one you use. Let's suppose that Joey and I are in a group and we decide we're going to do the gray. Okay, so we find the equation of the gray using the same process we used. Joey, any ideas how we would find the location of Q? If I know the gray line and the blue line, how do I find Q?
I think you could, I might be wrong, but if you look at like the gray line and the blue line, well, I actually don't know.
Anybody else?
Could you find the midpoint of the blue line?
Nope, because it's a line, has no midpoint. How do we find the point of intersection between two lines? Anybody? Okay, I'll leave you to work that out with your group. That's something you've done a lot in this class and you should know how to do it by now. Any questions before I cut you loose? Remember, this problem is what you're going to turn in as part of your notes when everything is said and done. Okay? Anybody need any more of this before I send you to your groups? All right, go get them. Lily, where are you going?
Cheese it.
Jessa, how about you?
Kardashians.
Jessica?
Cheez-Its.
Ella?
Cheez-Its.
Brooke?
Pirates.
And Talia?
Kardashians.
Kardashians. What's up, Power Rangers? So what do you two knuckleheads want to do? Do you want to stay as a group of two, or would you want to move to another group? Do you want to try and convince people to join your group? What's most advantageous for both of you?
I don't really care.
Yeah, me neither.
I mean, I don't really know any people in this class anymore, so.
Okay, you've lost all your friends?
Yeah.
Okay, so are you comfortable with just the two of you, or do you want to disperse and go to another group and make some new friends?